Okay, hello everyone, and welcome to the first presentation for the department day today, which is introducing the field of mechanical engineering. And thank you for your time, and I hope this session is very beneficial for you, especially the freshmen. Before we begin this presentation today, first of all, if everybody can hear me clearly, then please give me a thumbs up or write in the chat something. Am I audible? Okay, I will try to speak up. Am I audible now? Okay. So before we start this presentation, there are a few things how this session will go. I will be the moderator today, and which will be a very important presentation today because the field of mechanical engineering, to which I am myself also affiliated to, is some people also call it the mother of all engineering, and you will get insight into what this field is about, what the prospects when you choose this as your major, in terms of job, in terms of industry, in terms of internship opportunities and everything. As far as this session is concerned, I think Feng will present everything you need to know about this major in his presentation. And after the presentation, there will be a question answer session. And for the question answer session, I am sending a link in the chat. So if you click on this link, you will go to a web page, which is a Slido web page, and you can send your questions there in a live Q&A. When you post the questions there are a few options that are available. For example, sometimes there are many common questions. Some people might want to know about the credit requirement for this major field. So somebody already asked that question, so you can upvote that question. So if you go to that screen, after clicking the link, you will go to KISA Department State Mechanical Engineering, if everybody can follow me. And there, click on the Q&A tab, and here you can type your question. As soon as you type your question, it will appear to me, and I will address this question to the speaker, and he will answer your question. And if you think somebody already asked the question that you wanted to ask, you can upvote that question. For example, let's do a trial. I will send the question myself. Right, so now somebody anonymous posted question 1 sample, right? So there's a upvote symbol here that you can click. It's a like symbol. So if you give this question a like, that will make it easy for me to gauge which questions are important or how many people want to ask this question, and I can address that question preferentially to the speaker, right? So that's that, and let's begin with the presentation, and now I will hand over the session to Frank.
All right. Hi, I hope you guys can hear me clearly. Sorry for the internet connection problem. My name is Zhuo Feng, you can just call me Lee, and I'll be presenting a bit as helpful for you all in deciding your future major. So these are the contents that I'll be talking about today. And if you have any questions, feel free to jot down the slide number for reference purposes later on the Q&A session. Okay, I'll proceed with some of the introduction of my background. My name is Lee, and I'm from Malaysia, and for reference purposes, I do speak Korean. And I completed my bachelor's degree here in engineering under the individually designed major. So I took courses from computer science and also business technology management. And I'm now in the main campus continuing my master. So this is my lab's name, engineering laboratory, ICA lab, and our research focus is mainly on mechanics and materials. So I compiled a few points to let you see whether you actually enjoy what you're going to learn in this department. My opinion, I think that if you enjoy studying maths and physics overall, with a little bit of chemistry, you will definitely do well generally in all the courses that you're going to learn here. Plus, if you do enjoy hands-on engineering, coding, simulations, building your own models and systems, and can work well in a team. Or I definitely think that your interests do align well with what you're going to learn and experience here in this department. So I'm going to talk a little bit about the specialized fields in mechanical engineering. If you actually visit the website mechanical engineering homepage, you will see that the specialized fields are being categorized into these 5 main categories. We have design manufacturing for reliability. We have multi-transcending scale engineering, energy generation, efficient sustainability, biomedical engineering, and also intelligent mechatronics robotics. So the names of the professors and the labs are all listed down respectively in these categories. So you can feel free to you really like that lab. So I'll proceed to explain the few types of in our department. Before that, let's have a look at the graduation requirements. If you kais.ac.kr, somewhere in the link below, you can actually check the graduation requirement for mechanical, and you will see the requirements listed as elective basic courses, some mandatory major courses you have to take, and some major elective courses, and also, of course, some research courses. Right, so now let's look at the 3 types of courses available in our department. We have the assignment-based courses, we have lab-based courses, and also research-based courses. Course experiences and contents will definitely differ a little bit due to the pandemic situation, but I hope that offline classes could be proceeded soon and also safely. Well, let's look at the assignment-based courses. For the elective major under the basic category courses, like solid mechanics, fluid mechanics, dynamics, thermodynamics, etc., you basically learn about theoretical knowledge, and assignments are always homework-based. Just have to keep solving problems. And for elective major and advanced courses, you learn more about each advanced knowledge in specialized fields. An assignment will come in the form of homework, to participate in discussions, understanding materials and processing. You actually get sand casting. So we will give a structured mold, something like on the right, and using sand casting. And we also require to assemble and set up our own 3D printer, and we also some special experiences that you can actually get from these courses.
I'm sorry to interrupt. Can you please repeat the previous slide because your voice was choppy because of some internet issues?
Oh, okay. This one, right? So this is, yep. So basically, you get and print our own in the 3D printer courses, which is one of the core part in mechanical engineering. So you can see the courses are being listed down in mandatory courses and some other categories. And I'm just gonna show you some of the course contents that I experienced during my semester. So this is the course Mechatronics System Design. We were required to build a robot that can perform autonomous parking and autonomous driving on its own. So I'll show a short clip of it. The robot has to travel within the black. I'm just gonna skip the way actually like part of the And for the engineering design course, our team had to create a system that is suitable for the team, which is smart factory for that semester. So our team built a smart 3D scanning system that can actually plot the contours of the surface out on the computer and analyze it. Next, we have Capstone Design 1, which is one of the most interesting and one of the mandatory courses that you have to take in your undergraduate period. So in offline courses, we have to build a robot that can actually pick up blue-colored balls in the map and actually send it into the designated goal using visual recognitions and also autonomous driving. So, but let me see if I can share. Right. So if you go to YouTube, you can actually find this video. This is how the robots should actually look like and complete the missions in offline courses. Offline not able to be carried out. Well, all of these courses have to be performed online and changed to simulation based. As you can see on the robot has to perform, but we have to create, design our own robots in SolidWorks, and also to let it travel inside this virtual map built by the TA. So all the final demonstrations are live streamed on YouTube. So if you go to YouTube right now, you can actually check and see how the teams we previously had performed. It would be great if I can also share a short part of the video. Just 1 minute. Yeah. It's something like this. So this is the car. I guess the internet connections isn't really good. But yeah, as such, everything is carried out in online simulation and it takes place online. So even if we're not in Capstone Design 1, Capstone Design 2 KAIS, you can search a lot of videos on YouTube. So I'll continue back to my presentation. Okay, right. So also in Capstone Design 2, Capstone Design 2, can you hear me clearly?
Actually, Feng, your internet connection is lagging very severely, so your voice is very mushy. We are not able to understand anything. Yeah, okay, I think you'd have to repeat the previous slide.
Is it okay right now?
It's better.
Okay. Right. Sorry for the connection problem. And well, basically, you do everything online simulation design too. It's exactly the same with suspensions and to reduce the vibration of the robot overall. We carried out SLAM, which is also known as simultaneous localization and mapping. Carry out visual recognition and machine learning to identify whether the picture is a cat or a dog and to place in different colored balls respectively. Right, so now let's move to the research-based courses. We have two research-based courses mainly, which are the individual study and undergraduate research program. URP, basically you have to talk with a supervising professor, discuss about a small project that you can work on, and actually send in your application to the department and wait for their verify to continue the research activities. On the other hand, individual study, which has a course credit of 1, you can just talk with a professor of the lab of your interest, and actually he will prepare some small projects for you to actually understand more about this lab and more of their research. Because the 3 main types of courses available in our department, but how well are the courses actually being delivered? Challenging, and also well prepared. Professors are planning, and no worries, they do speak very good English in general. And especially the roles of TA, they're very helpful in answering your homework problems, and also especially important in lab courses as well. So, right, so now let's look at the suggested roadmap of courses that for you to plan out your courses throughout your undergraduate studies. If you visit the mechanical engineering website, you can actually search a course timeline. They shared the course timeline and categorize it based on the 5 different specialized fields of interest. But for my advice is, it would be best to complete the 4 basic courses before your junior year: solid mechanics, fluid mechanics, dynamics, and also thermodynamics, so that it does not clash with the other schedules of the advanced courses that you want to take. Also, try to complete these 3 mandatory courses before senior year, which are basic mechanical practice, mechanical engineering lab, and also engineering design. Because in your therapy, and both of these courses are very time consuming, so it would be best to avoid. This is how the course timeline is being scheduled in the mechanical engineering homepage. Generally, if you want to graduate in 4 years, I would say that it would be best for you to take a minimum of 18 credits for your first finals. The courses that I took during my undergraduate years, my personal interest was more towards solid mechanics. So as you can see, the elective, major, and advanced courses that I took were towards that field of interest, like mechanical component design. And then we have the foundation of stress analysis, reliability, deformation, materials, tensile mechanics, contact processing. So you can adjust these elective major courses by your own. And okay, so now this is one of the most, I would say, most important part of the presentation today. My opinion, right? First, I think that our department has a very good variety of courses and research labs, ranging from robotics, biomechanics, based researchers, mechanical engineering, bachelor degree is a very general engineering level. Here at KAIS, you will have a very huge opportunities to explore the different branches of specializations available in mechanical engineering. And next point is its flexibility in future specialization. As I mentioned, mechanical engineering at bachelor level is very general. So in cases, you can choose different branches or specialization. And also, if you think that after you got your bachelor degree, you felt that you might want to switch the departments, I think it is relatively easier compared to some other departments if you wanted to switch during your graduate studies. Also, the courses that we took in undergraduate level is actually quite useful for us to develop a foundation of technical skills. in your graduate studies or also in the industries. And lastly, if you do plan to continue your graduate studies here at KAIST, research labs in our department collaborates with the industry a lot. So I would say that in somehow shows how applicable the ongoing research are in our department. For drawbacks, I will only mention two important ones that might be the main concerns for international students. First one, notices and emails are usually in Korean, and except for some important emails. So notices and emails regarding opportunities like job opportunities, seminars, forums are usually sent in Korean. But on the other hand, most of these opportunities are actually provided by the Korean companies. So everything will be carried out in Korean actually. But for international students, sometimes you might get flustered and confused on the significance of the emails that we receive. And secondly is the possibility of language barriers in projects. As you all know, mechanical engineering is very in group members and be a little difficult sometimes. There are actually not many international students in this department too. So like meetings and discussions with TAs and professors can be enforced to be carried out in English. Sometimes communications between group members, I think that this can be overcome if you're more initiative in the projects, and also it depends on your group members' fluency of English. Right, so I'm just going to talk a little bit about job prospects and what graduate opportunities you have after the bachelor's degree. Two-line fairs and recruitment days by Samsung, LGs, Hyundai Motors, etc. On one condition is that you should be quite well versed in Korean and are able to adapt to their culture. And if you do plan to continue your graduate studies here in KAIST in mechanical engineering, my advice is to utilize your semester breaks or even your regular semesters to apply for individual study, because it's not a very huge burden cost, but it allows you to actually experience each different lab environments and their research focus. Because as a graduate student, I would say that student experiences are very dependent on professor and the lab environment itself. So I will not talk too much about it. And also it's to your personal advantage if you actually are able to converse in Korean and also to adapt to the culture. Right, so whether or not you're gonna continue your studies here in mechanical engineering or some other department, I just want to give you some final advices. Always keep track of the semester that the courses are available. Some courses are only available in spring semester, some courses are only available in fall semesters. So keep track of it, and also do frequently check your graduation requirements. Do not hesitate to ask for explanations in English and try to be more initiative. Also, try to embrace the cultural differences that we have between your own culture and Korea's culture. And do try your best to learn Korean, because it's gonna help you a lot living in South Korea. And lastly, expand your network in KAIST. Try to meet more international students and more Korean friends. And of course, do enjoy your undergraduate life. So yeah, I really hope that the pandemic will end soon so that you guys can experience KAIST here in South Korea. Because, well, I think undergraduate life shouldn't be just Zoom meetings and just books. And yep, so thank you for your attention, and well, feel free to ask any questions and contact me on the email below if you have any questions. Thank you.
Okay, thank you very much, Feng, for such an elaborate presentation. And if the participants, if you have any questions, since there aren't many participants anyways, so you can unmute yourself and ask the question, or you can write it in the chat, or you can write it in the Slido link that I sent earlier, any way that you feel convenient. I think we can manage that. Are there any questions?
Hello.
Yeah, hello, Rahul. Go on.
Hey, hey, nice to meet you. I'm actually confused between majors like aerospace and mechanical. So, is it a good choice to like choose both and do a double major?
Well, so personally, I think these two majors are quite different in terms of basic courses. It might be same at basic courses, solid mechanics, until year 2 level. The courses might be similar, but when you proceed up to the 3rd and 4th year, you're going to learn quite different stuff. Aerospace engineering department, you're going to really focus on aviation's flight mechanics. But in mechanical engineering, you're going to be focusing more on designing, constructing stuff, or even learning of materials. So double major or not, it's up to personal preferences. But if you would like to do that too, I would also think that's quite a good decision.
Thank you.
Are there any other questions? Frank, if you don't mind, can I add a little bit to Rahul's earlier question about choosing aerospace or mechanical? Because I am also from mechanical engineering and I did my master's and now I'm doing a PhD in mechanical engineering. As far as mechanical engineering as a major is concerned, it's, you could say, a parent field to many other fields. And one of those fields is aerospace. So if you choose mechanical as a major, then you will have most of the courses which are very similar, if not altogether downright like same to mechanical engineering in aerospace engineering. If you choose mechanical, you will have those courses and some other courses which are only pertinent to mechanical. And then later on, when you go for your master's and further studies, you can choose aerospace as your area of interest or your specialization field. So you can do a master's in aerospace afterwards. And in mechanical engineering, there are other fields. For example, one of the most prominent field is robotics, which is currently booming because all the systems are being automated in industry these days. So you can specialize in robotics. And one other field is manufacturing. There's a big sector of manufacturing and it requires mechanical engineers. So you will learn about manufacturing processes, their optimization and everything. One other field is obviously material research. So you can specialize in the area of material to make next generation mechanical devices. One other field is automobiles. So these fields are open if you choose mechanical as your major. But if you choose aerospace as your major, you will end up having courses which are similar to mechanical engineering, but you can't specialize in robotics. You will have a focus already in aerospace. So even if you go for robotics, it will be specialized or more specific towards aerospace applications. And you can't come to the manufacturing sector, you can't go to the material, or even if you go to the material sector, it will only be pertinent to aerospace applications. And you can't go for the automobiles, which is also a big sector and a big industry. So it's your decision at the end of the day. Choose carefully. And I think both fields are, like Feng said, very different and also very diverse. But mechanical is a parent field and aerospace is somewhat a corollary or a child for that, or a branch.
Yeah. So it's like better to choose mechanical now and then maybe do aerospace as my master's.
It is one viable option, but like I said, it's your decision because aerospace in itself is a very vibrant field and it depends on your situation and your passion or interest. So if you're more towards avionics or aerospace systems or designing rockets or air vehicles, then maybe you should choose aerospace as your major, and then you should pursue that as a field. But if you want to keep your options open, then maybe you should go towards mechanical.
Thank you very much. That was very helpful.
So does anybody else have any question?
May I have a question?
Yeah, please go on.
Yeah, I want to study the robotics major, but I really want to, when I study robotics, may I have to study a lot of coding like an IT, or I have to focus more on the mechanics?
Can you repeat the question? But the internet was lagging a little bit just now.
Yeah, An wanted to know that he wants to pursue robotics as a field of interest, but he is confused that for robotics, is there more towards coding and IT, or is more towards a mechanical aspect, like solving for mechanical mechanics of the part or something like that?
So for robotics and mechanical engineering, I would say you need to do a certain amount of coding, but not the coding that you're going to do in departments like computer science, because that's more like you're understanding the principles and why and how to do it behind the codes. For mechanical engineering, it's more like you're actually using the codes itself. You don't actually study the story behind these codes. You've actually practically used those codes. So you need a certain amount of coding. And you need a certain amount of understanding the mechanics itself too, because for robotics, there are a lot of simulation programs going on. And to actually understand those programs, to write those programs, you actually need quite a number of mathematical base, I would say, theoretical knowledge on dynamics especially. So I think it's a very good combination of both. But if you're more inclined towards the theoretical side of coding, that would be computer science. You learn about data structures and systems programming itself, rather than using those codes and apply it on a mechanical system.
Yeah, understood. Thank you so much.
So are there any other questions? Feng, I have one question for you, and I hope this proves beneficial for the listeners as well. When you graduate as a mechanical engineer from KAIST, from a job perspective or an industry perspective, what are some of the prospects which are available? What are some of the fields that are available that you can land a job in? For example, in Pakistan, if I give an example, in Pakistan, the most attractive sector is the automobile industry. So once you graduate as a mechanical engineer, chances are that you'll land a good job in an automobile company. But in Korea, what are those prospects?
Well, in Korean, most of them, the friends that I know for Koreans, they actually enter Samsung those as a basic researcher in projects. And also many of the Korean students, they tend to further their studies up to master and PhD levels so that they can actually, join a company as a research engineer and lead the projects. So the differences between bachelor degree, PhD, and master's degree is that when you go into projects, if you're a bachelor degree, you basically do stuff at the bottom. If you are having a PhD degree, they basically think that you are capable enough to handle projects, to solve problems. So they actually hand you over to higher positions in research projects. You lead the project, you lead the teams that might be filled with masters and undergraduate students. And you might even be transferred to some other departments, because as a PhD holder in mechanical engineering, they think that you have the capability to handle projects, not just research-based projects. You can basically solve problems already. You can identify the problems already. So that's the, I would say in Korea, that's the biggest differences. So back in my country, if you are a mechanical engineer with bachelor degrees, you might move into manufacturing industries. So for Korea, that's the case. In my country, that's the case, and it depends on where you actually want to further your jobs, in which country you want to actually go after your degree.
Okay, thank you very much for your answer. If there are any other questions, you can unmute yourself and ask the question. And if there aren't any questions, then I would just like to make like an open session of sort. So because we have very few freshmen in this session, so we can ask them one by one, what are their inclinations, or what are the chances they choose mechanical or any other field. So starting from Tung, what do you think you're going to choose as a major after the semester or after your freshman year?
For me, I really love the mechanical engineering. Now I'm yeah, in the next semester I will decide to the mechanical engineering and focus more on, yeah, I quite confused a little bit between the manufacturing and the robotics and auto, yeah, and controlled, yeah, I don't know the, is the controls, yeah, it's control system. Yes, for me,
Control system.
yeah.
So as part as a mechanical engineering course, you will learn about control theory and control systems, and also some aspect of robotics, and also like manufacturing, which is very essential for mechanical engineering. So you will have courses like machine design, like which is Capstone Design here in KAIST. And so you can specialize in manufacturing. You will also specialize in robotics, which is part of manufacturing these days, because like I said, many of the industry are going towards automation. And so robotics and manufacturing are somewhat mingled these days. So yeah, best of luck for your major if you made a decision. What about Isa? I know about her. She's going to choose civil engineering.
I'm just monitoring the session because.
But why? Why civil engineering?
Oh, I'm going to do the environmental track. So, and that's really, I want to maybe solve environmental problems in the future. That's why I chose that course. But and mechanical engineering sounds fun. So for those who are taking that, good luck.
Thank you. And what about Mark? What are you going to choose as a major?
Yeah, for me, I plan to major in mechanical engineering. Yeah, I like a field of robotics, so maybe this isn't my best choice.
Yeah, I think Korea is the right country if you want to choose robotics as a field of interest afterward, because there is a lot of research and there are a lot of funded projects for robotics these days. So good. Rahul.
Yes, for me, I'm still confused between aero and mechanical, because at this point of time, we decide our interest from our high school studies and some YouTube videos, right? Like we haven't experienced yet. So
yeah, but I think even if you choose mechanical as a major for now, you can always switch to aerospace if you feel later that that is the right decision. Because like most of the courses, they're overlapping is similar. So you can transfer the credits from mechanical to aerospace or aerospace to mechanical. I hope that's true,
I can
right?
do that only for 3 courses, right?
Mm-hmm.
3 or 4 of them.
All right. So my suggestion is that you meet people who are already in the field of aerospace, who graduated as aerospace engineers and mechanical engineers, and then you ask them about like what are the prospects after you, because then that will enable you to imagine after becoming a mechanical engineer or an aerospace engineer what your life or your professional life would look like, and then you'd be able to make a better decision, I guess.
Yeah.
Mm-hmm. What about Arseny?
I think I'll choose electrical engineering for now, but I'm looking for like the right combination of double major with electrical
you're going to
engineering.
do a double major?
Yeah, I also have a question, like what? Like according to the bulletin, if you choose major plus minor, it's gonna be 50 plus 25 credits, right? To sum up like to total 75. But if you go for double major, it's gonna be 40 for each field, so 80. So not that big of a difference, like seems to me. Or am I wrong in some sense?
Frank, can you answer that? Because I'm not sure about this.
Yeah, I think what you said is you do a double major and a minor, you actually need to take less courses and they usually spend up to 4.5 or even 5 years to complete their bachelor's degree here. So if you plan to take major and minor, the courses are definitely relatively less compared to double major.
I see, thank you.
And moving on to Ezrek. What are you going to choose as your major? Have you made up your mind?
Oh, hello everybody. I think that I will choose computer science, but it was really interesting just to come here to hear your opinion about other majors also, so that's why I'm here.
Yeah, very good. Best of luck for your major. And like everyone here, I would like to give a suggestion that before making up your mind, do attend all the other presentations and learn as much as you can about other majors as well. Like Ezra here, she's going to choose CS, but she also showed interest in this mechanical field and she's here. So get as much knowledge as you can about all the fields and then make very, you could say, elaborate decision or thought through decision. What about Ilham, the last person today?
Yeah, hi. I just joined this Zoom session a few minutes ago. I couldn't join from the beginning, so maybe if there's a recorded version, I'm gonna watch it or gonna something. Right now, I think I'm going to choose mechanical engineering. Actually, before when I applied to KAIS, I chose aerospace engineering, but so yeah, it's between those two. But right now, after talking to seniors and all that stuff, I'm thinking of mechanical engineering more.
Yeah, that's great. Like we have recorded this session. We're going to upload these recorded sessions on our Facebook page, KISA's Facebook page. So you can find the recording there. And even if you have some questions after that, you can contact any one of us and we will find the right person to answer those questions for you. And also, yeah, YouTube, we will upload this video on YouTube as well, on our YouTube channel. All right, so if no one has other questions, I guess we can end this session right now. And even if you have a question after the session, it comes to your mind, you can always contact Kisa and we will find someone to answer that question for you. Okay. And with this, I would like to thank the presenter Feng for his time and presenting about the mechanical engineering field. I would like to thank all the freshmen who joined this session today and Kisa members who worked hard to organize this presentation session. Thank you very much, everyone. Thank you, Feng, and goodbye. Have a good day.
Thank you, everyone. Thank you again, Frank, for volunteering. We will contact you about the